Hey everybody, welcome to Sarah Olivera's cooking show. So for today I'm going to be taking some of my requests from my many fans who have all been asking me to make the best food ever, which is...
Cookies.
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 Cookie.
Cookies.
You heard it, we're going to be making the best chocolate chip cookies in the world. But what goes into making the best chocolate chip cookies ever? What's going on in that oven to make such a delicious dessert? Believe it or not, it's all about that chemistry. So, let's get started. First off, the ingredients. We're going to be using sucrose, which is sugar, a stick of fat, which is butter,
An egg.
an egg is made of an emulsifier, which is a food additive used to stabilize processed food, it's albumin, which is a form of protein that is soluble in water, fat, and protein, which are very large molecules made of amino acids. We're also going to use flour, which forms gluten in molecules. Baking soda, which is also called sodium bicarbonate, which serves as a base, and I just spilled some. Also, just a little bit of sodium chloride, which is also known as salt. And of course, it won't be complete without some chocolate chips for flavoring. Step 1. Preheat the oven to 375 degrees. The temperature of the butter also determines how good the cookies come out. Chilled butter makes smaller cookies. Room temperature butter, about 21 degrees Celsius, makes medium-sized cookies. And melted warm butter makes thinner and larger cookies. But why? This has to do with the kinetic molecular theory, and how when the butter is heated, the molecules move faster, bumping into each other, thus making the cookies spread out and become bigger. Flour forms gluten molecules, which makes the mixture more elastic and stretchy. Gluten is a water-insoluble protein that is formed when water is mixed with wheat flour. Step 2. Mix in the flour, the baking soda, and the chocolate chips. This is why the flour is added later on, to ensure that the gluten does not get overboard with its gooiness. The baking soda, or shall I say, sodium bicarbonate, then softens the mixture and raises the dough's pH. Baking soda is a base, so it reacts with acids. Cookie dough typically gets its acidity from its dry ingredients, like brown sugar. Although, the acid and the alkali don't truly mix until the butter melts, so the chemical reaction only starts once it's in the oven. Step 3. Drop dough about 2 inches apart on a cookie sheet. The results of the cookies depend on the size of the cookie dough you place on the sheet. Carbon dioxide bubbles form throughout the whole cookie, but only the edges of the cookie become caramelized. Step 5. Place the cookies in the oven for 8 to 10 minutes to bake. When you put the raw cookie dough into the oven, you're setting off a series of chemical reactions, and it all starts with a spread. As the cookie dough starts to heat up, the butter inside of it melts. The dough loses its structural integrity and spreads out. When the butter melts, its molecules are starting to move a lot faster, making the dough spread out. While baking, the heat lets the sucrose, which is sugar, to break down into glucose and fructose. This causes a polymer chain, which allows for the cookie to have a light brown, shiny crust. The cookie starts to rise at about 212 degrees Fahrenheit, and the water in the dough turns into steam. It rises as though vapor is pushed through the dough, and eventually the baking soda starts to break down into carbon dioxide gas, which makes the cookies rise even further. All these gases leave little holes in the cookie, which makes it light and flaky. The fat, which is the butter, controls how much gluten forms from the flour, which causes its lighter texture. The fat and the protein from the egg yolk serve as an emulsifier that holds the dough together, which is the main purpose of an emulsifier, which is also to stabilize processed foods. But how does the cookie get its caramelized color and amazing flavor? Well, this is when the magic really starts to happen. Just as the cookie is almost done baking, two chemical reactions fill it with hundreds of flavors and give it its characteristic brown hue. First off, there's caramelization. As sugar molecules in the dough begin to break down, they go from clear, odorless crystals into a brown liquid that's full of smells and taste. Then comes the Maillard reaction, which is a chemical reaction between amino acids and reducing sugars. It gives brown food such as cookies or bread its amazing flavor. In the process, hundreds of different flavor compounds are created, which in turn break down to form even more flavor compounds. The Maillard reaction only happens over 140 degrees Celsius. This reaction packs the cookie with an even richer taste. The reaction involves not only the sugars in the dough, but the proteins from the egg and the flour as well. Step 7. Now let's remove the cookies from the oven and let them cool down. The cooling allows for the completion of the caramelization process, which gives it the brownish color, and it also allows for the structure developed by both the gluten and the egg to set. And that's how the cookie crumbles. See you next time, guys. Make sure to follow and subscribe to my cooking show.
Cookies.